time you take a breath, you inhale millions of tiny bits of material called aerosols. They're basically just solids and liquids that are floating around in the air, like smoke, smog, and even clouds. And there are so many of these aerosols in the atmosphere that they can significantly impact global climate change. With most aerosols, as we heard today, they can warm, especially if they're black. But it really depends on their color, white, black, or brown. So you've probably noticed that when you wear a black shirt in the sun, you get hotter than if you were wearing white. Well, I like to think of the atmosphere as the Earth's t-shirt. And if it's full of black aerosols like smoke, well, things are going to heat up. But if there's things like clouds, it'll cool the climate down. Now, brown aerosols fall somewhere in between those two and can actually have a slight warming effect. But what makes them really interesting is that when they absorb sunlight, they can actually change color from brown to white. And that changes their effect on climate. I study how these aerosols actually change color when they're exposed to light. So, I make these aerosols in a lab using a machine that I built. It's called Mallory's Aerosol Generating Irradiation Chamber. But I call it magic. And it can make aerosols under controlled conditions in the lab by mimicking the processes that actually make the aerosols in the atmosphere. So once I make these aerosols, I can collect them, shine artificial sunlight on them, and measure how quickly they change color at different temperatures. What I've found is that at warmer conditions, this color change happens faster than at cooler conditions. And this is important because it means that brown aerosols in cold parts of the atmosphere will stay brown for longer and contribute a warming effect for a longer period of time. But why does this even happen? Well, we suspect that it's not necessarily a temperature effect. These aerosols are essentially the consistency of peanut butter. And can you imagine trying to swim through peanut butter? Probably wouldn't move very fast. But what if we were to heat it up? Then the peanut butter would start to melt, and you could swim faster. The same thing happens with aerosols. As they get warmer, they get more liquidy, allowing the molecules inside of them to move around faster, and thus change the color faster. Aerosols are vital to our understanding of climate change. If we want to implement the most effective environmental policies, we need to know more about these aerosols. My work gets us one step closer and fills in one more piece of this climate change puzzle. Thank you.
Thanks, Mallory. That's terrific. A few years ago, someone came to me with a proposal that if we painted all of the roofs in the UC system white, the impact it would have on climate, and it was amazing. I mean, just by that one simple thing, and it sounds like your research is taking that just a step further into the aerosols that are produced.
Right. So generally, aerosols are thought of as being white, but sometimes they can change color, and so that's something that people aren't really taking into consideration at this moment. So it's something that if we want to have really good climate models, that's sort of things that we need to take into account.
Well, thank you. It's fascinating research.
Thank you.